yesterday. And then I will just go through where I picked off yesterday to the end of the exam. And then that way everyone was here yesterday or could have stayed. We'll have seen all the exam, and then I'll wrap around and start from the beginning again. So, and of course the intermediate doesn't work, so let's I can log into graphene. All right. Yeah, I'm gonna put it up later on today after this recitation. So the question was, is the exam up on CourseWorks? And the answer is not yet. And the reason not yet is I want to go through it at least once before I publish it, because without my going through it at least once, it would be terrifying. So I want a certain group of students in the class to have seen it at least once. All right, so last question that I did was, where did I find this? Was the transaction one. So I'm not, that was the one I left off with, so I'm gonna wrap around, go through the rest of them. Question 8 is on star schema. And so, problem statement, your experience with W411 have led you to decide that computer science, data science, IEOR, et cetera, are not the fields for you. While being very talented and good at the domains, the topic brings back memories. You decide that the world was a better place before computers, and you want to study the world. You want to become an archaeologist. One day in a dig, you uncover what is an advanced computer inside ancient remains. This is game-changing. This is proof of ancient aliens. Despite your aversion to technology, the opportunity is too great, and you decide to study the system. After powering on the device, you discover that it contains a database, and that's going to be the Sequila sample database. That's the one that I mentioned in the introduction, that you can follow the instructions on the MySQL website to install it. Probing the database reveals that it contains information about video rental stores. Wow, this is really old. Seeing a killer breakthrough paper uncovered the video viewing habits of Earth visiting ancient aliens. You decide you must apply data analysis to that. A snarky voice sounding suspiciously like the annoying DB professor says use a star schema. The two most important facts for the fact table clearly are a rental event and the corresponding payment for that rental. So those are the two facts that are going to go into the fact table. How many of you were not in the lecture on Friday? All right. So you'll have to go through either the video or the notebook to just get the information on the star schema. But the facts for this fact table are the rental and the corresponding payment. You must build a star schema containing the facts, containing a fact table and dimension tables, enabling you to realize the data. So your task is define the DDL statements that create the fact table and dimension table. You must decide what the dimensions are. Write SQL to load copy data from the base Sequila tables into your fact and dimension tables. And then write 3 queries. One demonstrates a roll-up operation. One demonstrates a slice operation, and one demonstrates a dice operation. So that's the next question. So the answer to this one, that's that. So the answer to this one, let me go find my SQL. All right. This is the Sequila database. This is the standard example. It's kind of the standard sample SQL database. And so you can see that it is a database primarily about movies and videos. So there's actors, addresses, blah, 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 blah. If you ever want to just take a quick look at what's in the Sequila database, you can just go out and ask to see the Sequila DB schema. There's like a bazillion versions of this because this was kind of the canonical example. This is the full schema, or most of the full schema. It's broken into, let's see whether we can make this one bigger. It's broken into kind of 3 broad areas. One is the customer area. One is the business area. And then one is kind of the movie area. So this is information about customers. This is information about the business. And then this is information about the inventory. So I'm just basically going to have to get my reading glasses, make it a little bit bigger. So I can just point at the screen while I'm getting the reading glasses. So you can see that what's in the inventory is basically films, because it's a video rental store. So there's a bunch of stuff about the films. What category is it in? What language? Actor, film, etc. So it is not too dissimilar from the information that's in the graph database. Customer is country, city, address, customer. And then if you look down on the business side of things, there's staff, store, payment, rental. So the facts in this database are primarily going to come from these 2 tables. All right, so they're going to come from rental and payment. So if I go back in here and this is the table that I built that has the rentals and the facts. So I'm just going to copy this statement over because I can make it bigger in the browser. So we'll go back to the exam. And I'm just going to add a cell. Percent. I'm just going to try and run that. So we'll go back and just basically do limit 10. All right, just go back and do limit 10. All right, so these are the things that make something a fact. When did it happen? So what was the ID? So every rental, if you go take a look at the rentals, it's just called rentals. And what's it called? Rental, of course. So the rentals, they generate an auto increment ID. So that's the ID for a rental. What was the date? Inventory is a foreign key into the table of movies. The customer ID is a foreign key into the table of customers. The return date, staff ID is a foreign key into the employees. And then when was this record last updated? And then if you do same thing for payments, this is the information about payments. So we'll just go run that. And so Again, it's got an auto increment ID, who is the customer, who is the staff, the foreign key to the rental, the amount, and the date that the payment occurred. So the facts are basically a join and a project on those two tables. So if I go back in here, this is my rental payment facts. So we're just going to do the same thing here. So what was the ID of the rental? What was the date? What was the customer ID, the inventory ID, the customer ID, the amount, and the staff? So you can see that rental ID, rental date come from the rental table. Inventory ID comes from the rental table. Customer ID can come from either one of them. The amount comes from the payment table, and the staff ID, I think, comes from the payment table. So the first step on this one is to just basically go and create the schema. And so I'm going to copy to the clipboard the create statement. And so we're just going to go down here. You don't need to run it in your submission. You just need to show the one that you did. And so this is what the create statement looks like. So I'm going to create a table, rental payment facts. There's a rental ID, a rental date, an inventory ID, a customer ID, an amount, and a staff ID. So those are the facts. This one you can get if you go back and take a look at rental. All right, so this is rentals. This is payments. You just join on the rental ID and then drop the fields you don't need. So if you basically, the query that does this is just going to be select star from rental, join payment on rental dot ID is equal to payment dot rental ID. Table rental, so what is it called? Did I type it wrong? From rental, join payment on rental.id. Oh, I've got to set this as the default schema. Do it again. Unknown column rental.id, so where's payments? And it is, it's in there. Rental ID. All right, so it's called rental ID in both places. So go back. That's just the join statement. So this is all the information. You clearly don't need all of that. So what you need is the rental ID, the rental date, The inventory ID, I don't think I actually use that. The customer ID, so I probably have to prefix these with rental. Customer ID. I don't care about the return date. I want the staff ID. I just picked the rental staff ID. Staff ID. The payment ID. And the payment amount. I think those are the fields that I picked. So this is a straightforward join. So I just go and run that. Unknown fee. Well, yeah, I know there's. Oh, yeah. Thanks. Unknown column rental in field list rental ID rental date unknown field unknown table rental rental ID from rental join payment on rental ID is equal to payment rental ID. All right, so I may have forgotten a column, but that's basically the query. So all you would really do is just something like this: create table, facts. I don't even know to as select star. Or sorry, it just says that select statement. So that's going to create the copy table. And you'll just go run it. So I'll pause so everyone can take their family picture. All right. So I'm not going to create it because I already have a rental payments facts table. Now, the thing about this table is what are my dimensions? Well, the first dimension that I have is an address dimension. And so there's an address ID, a city ID, a district, which is a generalization of state, city, country ID, and then the country name. So I'm just going to go and run this query in here so I can get it a little bit bigger. So we'll just go add a cell. And we will go run that. Just do limit 10. So you can see that these are just an address ID, city ID, district, basically state, city, country. And so those are the rentals. So that's the address dimension. Now, how do you build that? If you go take a look at address, it kind of has all of the information in it. I didn't use address 2, but I have district, city ID. I didn't use postal code. there's a country table in here. And so I basically just kind of get the country names by joining on the country IDs. But if you'll notice, the way this thing is actually built is it's pretty denormalized. So there's an address, right? But the address has the city ID. The city ID has the city name and the country ID. And then the country table has got the country ID and the country name. So step one on this to build that address dimension is basically select star from address, join city on address dot city ID. What did they call it again? Address dot city ID, and what is it in address? It is city ID. Where's the query I'm building? Okay, we'll just do it here. So it's going to be create. It's going to be select star from address, join city on address, city ID is equal to city dot city ID. I've got to put a, yeah, so just go run this. All right, so obviously I don't need all of this information, but I've got the address ID. I don't care about the actual street address. So I'm just going to go and select address ID. City ID. City. District. And country ID. So I don't need all of those. City ID is ambiguous. All right, so address ID, city ID, the city name, the district, and the country. Now, if you wanted to, you could create a temporary table to make it easier. The other thing you can do is to just remember you're getting the city. So I get the country ID. So I'm just going to call this A, join country. I'll make this smaller, as B on A dot country ID is equal to B dot country ID. And then I'll just select star from that. Probably would, but it might complain about it. So it might work. Yes, it would work because the rule is every derived table must have an alias. That's not a derived table. But you've seen how much fun writing these queries can be. So I tend to be very disciplined about aliasing everything. And there are basically old programmers and there are bold programmers, but there were no old, bold programmers. So I tend to just try and be as disciplined as I can. So that query is basically the dimensions. So the address ID, the city ID, the city. Apparently we had a video store in Afghanistan. I don't think that's there. Kabul, country, you have country ID twice, so I don't need it twice. The country in the last update. So all I'm really going to do here is just do A dot star B dot country, and that'll get rid of all the junk. And so that's everything I have. The ID of the address, the city name, district. In a real address schema, this would also be factored out. There'd be an ID and a name for it. They wouldn't put it in here like this because it's going to get replicated a lot. But don't worry about that. Country ID and country. So you can take your family picture of that if you want. For those of you, so in yesterday's recitation, somebody said, can I like post or share the notebook? My response was, so you want me to share the answers to the final exam too? The reason I let you take photographs but don't share the notebook is just the act of your typing in it and running it. It's just going to reinforce it. So you don't actually have to figure the details of the queries out, but you're going to understand them a lot better if you just type them in and run them once. If I just posted the notebook, everybody would just zip up what I posted and submit it, because you've got a lot of other work to do. If you get stuck and like can't figure your photograph out, right, they make this device that you can put on an Android phone or an iPhone, which is a telephoto lens, and you can use it. Just kidding. Just let me know, and I'll send you a cleaner picture of it. But just having you type it in causes you, because the hard part of this thing is, you know, it takes me like 3 minutes to figure this out. It's not that I'm smarter than you. I just have a lot more experience. It could take you 15, 20, 30 minutes to figure this out. And and you'd get all these weird errors. This symbol doesn't exist, can't find the table to your syntax area. So just showing the basic shape of the query in the code just makes it easier for you to go and type the answer in and understand it. So that's why I do this crazy photograph thing. But anyway, so that sort of builds the address. So you can see that I've got an address dimension, and I would just do, you know, create address dimension as create table address dimension as. So that's all that would do, is it would just create. This is not complete from my point of view, however. So I'm going to close all the other tabs. I'll close all the other tabs just to save space. If you'll notice, I actually have two dimensions. I have a customer address dimension, and I have a staff address dimension. So I'm not quite sure how this video store has offices in Australia, Afghanistan, Canada, the United States, UK, and France, but only 2 employees. They must have really great frequent flyer miles. But the reason that I do this is, and this is a common thing in star schema, is remember, dimensions, there are dimensions and then there are hierarchies. I'm not going to fill the fields in, but we'll just go back and get rid of these. So this is going to be, I'll make it a little bit bigger. Whoops. So this is just going to be country. And copy that. District. So this is what I'm doing here. City. And technically, the endings on these are, the source ending would be none, and the target ending would be. So unless I messed it up, that's the UML notation for a country contains districts. And then you would just do the same thing here. You can't really describe that correctly, that behavior correctly in ER diagrams. The best you can do is actually, foreign key relationships, but a district doesn't have a key. So city, so that's kind of the level of detail. And then the next thing that comes down here is store. So I'm just going to go set this to that. And the next one is going to be customer. And just going to go change these again. And then the final thing is a store has a staff. We'll do the same thing over here again. So when you go take a step back, there's actually, this is extremely common when you do star schema, is there's two dimensions, the dimension of the staff and the dimension of the customer, but they share a hierarchy, which is address. And the reason that I do that is I might want to ask the question, how many customers who live in Boston rented a movie? So I need to go up this one, but then on the other hand, I might want to say, how many stores in Boston rented a movie? And I might even want to ask the question, how many customers who live in Boston rented a movie in New York? And so this is a shared dimension, shared hierarchy, and there are two dimensions. So if you go back and take a look at the schema, I built the base address dimension, but then there's going to be a customer address dimension. And so it's customer ID, the core customer information, and then all the address stuff. And so the way that you build that is it's just basically select customer ID, first name, comma, last name, address ID, comma, I won't do that. Address dot star from customer join address dimension. Join. Sorry, I've already did the join on customer dot address ID is equal to address dimension and it doesn't like something. So what doesn't it like? Not unique table or alias customer. So address from customer join should just be a address dimension, right? From customer join address dimension. Non-unique table. Yeah, sorry. Sequila address dimension doesn't exist. Address ID, address dimension, did I spell it with dimension? Unknown table address, address dimension. By the way, this is why my lectures are never done until the last minute, because I'm constantly doing this. So that's the customer address dimension. So again, you would just create the customer address dimension table from that. And then if you basically go, right, this is the staff table. So it tells you a bunch of information about the staff member. So what I would do in this case is I would just basically say select star from staff join store on staff.storeID is equal to store.storeID. All right, so make that a little bit bigger. So that is the staff store relationship. And because I'm kind of lazy, I would just go create temporary table. T1 as, I'm just going to go make a temporary table. Duplicate column store ID. So this is, so it is going to be, get rid of these prefixes. So it's just going to be staff join store. And this one I'm going to do, I'm going to select star from staff and address ID from store address, sorry, store.address ID. Select star from select. It's going to be staff.star store.address ID. Staff.star store.address ID from, let's see whether that one works. Duplicate column address ID, of course. So it's going to be staff ID. Call the name. What's the staff number? So it's first name, last name. So go back over here. Staff ID, staff dot first name, staff dot last name, store dot address ID. Right. All right. So there's only 2 records in that table. Apparently they got lazy at this point when they were building the schema. So the next thing I would do is I do select T1 dot star address dimension dot star from T1 join address dimension on T1 dot address ID is equal to address dimension, address ID. Is that it? So we'll try running this one. You can see it's not a particularly interesting dimension because again, there's only 2 people, but there's a staff, then the address, blah, 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 blah. And so then you can just basically go and create, you know, staff address. I'm not actually going to do it because I already have the dimension, but you could just create the table as, and then at this point you would drop temporary table. So the temporary table thing is some of these joins, you have joins, joining joins, joining joins. So I just basically do them one temporary table at a time and then drop the temporary tables and I'm done because I'm only doing that once. The reason you don't use temporary tables in general is because when you create a temporary table, it writes the data to a disk, which may not be necessary, but since I'm only going to run this script once, doesn't matter. So drop table. And so that would be the script that creates the address staff and customer address dimension. So I would have accepted it if you just did those 2, because the other dimensions are kind of weird. So the other one that I didn't actually do it because it seemed kind of weird, but I would have accepted it for the addresses. You could do it around the films, like films, categories, genres, but that isn't a really good dimension because the film has multiple categories, it's got multiple genres, so it looks like it's kind of a weird dimension. So the only other one that I did was the date dimension. And so I'll just go back over here. And the date dimension is perfectly straightforward. It's year, quarter, month, and day. And so if you go back over here, you can see that it doesn't really matter what you call the first column. I'm not even sure why I called it payment date, but it's year, month, day, quarter ID. And so the first thing is you want it for rentals. So I'm basically just going to go select date from rentals. So just go run that. It must be rental date. All right, so not surprisingly, you just get back a bunch of dates. So how do you convert that into a dimension? Well, the next thing you do is you just go year of rental date. Run that. And it gives you the year. And then not surprisingly, you do month of the rental date. So now I'm going to get the month. So it'll show you what the month are. I just alias you also want to alias things as year, as month. And you're just going to do, I think it's called day of month or something. Is that what it's called? Of course not. Day of month, no underscores. As day. So it's rental day, year, month, day. And then the only other thing I just do at this point is quarter is equal to, sorry, quarter. It's going to be, it's ceiling. Yeah, ceiling of month divided by 4 as quarter. You may not like that. Yeah, unknown column, so it's going to be month of date. Unknown column date, sorry, month of rental date. Month of rental date. Let's go, so it's going to be the month of rental date divided by 4. And I'm just going to close that, right? All right, so now it gives me year, quarter, month, day. And so that's all you need to do. So it's going to be create date dimension as create table. Date dimension as that. Unfortunately, there are dates in 2 places. Union. You have to do the same thing. Select payment date. Payment date of year. And then day of month is payment date. So I'm not going to create it. I'm just going to run the select. So we're going to run it. Unknown column, payment date and field. So now we have to go back to payment. Oh, because it's got to be from payment. Right. So that's going to, because there are dates in 2 places. And so I basically need to go and make sure I get the dates from both places. And so if you go back and take a look at my fact table, somewhere back here. Yeah, I decided not to do the payment fact. You could do that if you wanted to. I just decided to do the amounts. So I decided not to do the payment date. I didn't think there was any value added. I think a real system probably would. But if we go back to my diagram, all right, what's going to happen is then we're going to have the obvious so that's the date dimension, that's the payment dimension. So I'm going to copy this one. I'll just copy a bunch of them. Just move these over here. We don't need that. Don't need that. And so it's just going to be year, quarter, month, and day of month. And so this is one dimension, the staff store dimension. This is the customer dimension. This is the day of month dimension. And so when you actually go and look at the star schema, it looks like this. Oops. It's going to be the facts. I can't remember what I called it. There's a customer address dimension. There's a staff store dimension. And then there's a date dimension. And so the relationships are the following. It's always, the start is, the way that I built this is the customer may not have had anything to do with that particular fact. No, that's not right. So if I have a customer, right, so a particular customer on a date may be related to multiple facts. If I have a fact, it's related to a customer. Same thing this way. So it's just going to be exactly one. And this. And then this one will be the same. And no, that one's one. And the ending's that one. So that's kind of the schema that I would have drawn. We're not going to get hung up if it's exactly right with respect to the endings, but that's kind of the star. Some people will be tempted to do things around inventory category. You don't need to do that. I will actually put a note on that in the actual exam when I release it. But that's a good enough star schema. Right. And then how do you do, so these are my dimensions. So the obvious question is, I asked you to do a roll up, a slice, and a dice. So who can, When I took my PhD qualifying exam on the database section, they gave me a bunch of table schemas, but they didn't say there was any data in the table schemas. And then they basically said, go run these 3 queries and, in your head and show what the output is. You can pick whatever data you want. And so my answer was, well, you didn't say that I couldn't say that all of the tables were empty. So the result of all those 3 queries is the empty table. Just kidding. And then I went back and did it for real because they have no sense of humor on PhD qualifying exams. And I just went back and did it with real data. But I would accept this. What is the simplest roll-up of this? Just basically select. So it's basically count of star, sum from rental payment facts. Unknown column payment. So what is it called? It is called amount. So what I've done basically is I've rolled up so I know over all customers, cities, states, countries, all dates, year, quarter, month, day of month, all staff, store, year, month, quarter, day of month, how many rentals have happened, and what was the total revenue. So I would accept that as a roll-up. It's like the simplest roll-up. So I took this huge multidimensional cube and just stomped it down into one single little cell in the cube. If you wanted to do something more sophisticated to that, you could then start doing other things. So, basically from where select would be country ID from customer address dimension Australia. Something like that. What does it not like about that? Because I need a where clause. From customer address dimension where customer address dimension dot country is equal to Australia. We'll go try that. There's probably something wrong with this query. Customer address dimension, customer address dimension, customer address dimension. So customer address dimension does not exist. Customer Dominion, this is because I can't spell. Dominion. All right. So there were no sales in Australia. I mean, just basically that would be another example, but I would accept this one. Just roll everything up. The easiest way, the other way to do this is basically I don't know whether I built this. So basically, these are my facts again. Right. So I can just basically say select star from rental payment facts, join customer address dominion on rental payment facts dot customer ID is equal to customer address dominion dot customer ID and so that has joined the facts with the customer address dimension. I can then basically just go do this as a join it's a date dimension as B on A dot date, A dot rental date is equal to date dimension dominion. This one I probably spelled correctly. Date dimension, what did I call that one? Payment date, not quite sure why I called it that. So we'll try select star from that. We'll just call that B. All right, so just go do that. Look at column name customer ID. This just gets really annoying. So I'm going to join those on the customer ID. So I'm going to select A dot star. So I'm just going to call this customer address. So I'm going to do rental payments facts star. And it's going to be B dot city ID, B dot city, B dot region. District. B dot country ID, B dot country. It should all be A. I'm going to join that, so that's just going to be that's A. So that's going to be A, 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 A. Don't need a B dot Payment date. B dot payment, B dot year, B dot month, B dot quarter, B dot day. From that query works, it's a miracle. Yeah, so I mean, basically, I'm not going to go spend my time figuring this out, but you can take a picture of this. It's mostly right if you want, but this basically would join rental payment facts with customer addresses, and then customer. Oh, so this is the problem, right? Duplicate column named customer ID. I don't understand why there would be, so it must be in here. Dot star. No, so this one's going to be rental payment facts dot star customer address dimension dot address ID. And that is going to be, so it's address ID, customer address. It's going to be city ID. City. And it is district. Country ID. And country. Custom address dimension. Address ID. All right, so it's not address ID because I took the address ID out of it. So it is customer address dimension. What do I call it in the ID? Customer ID. So I keyed it off of customer ID dot address because I rolled the dimensions up. So I don't need that. Unknown column, customer address dimension dot city ID. So what did I do here? Nope, it's in there. Customer address from secure rental payment facts, join customer. And this goes into the category of should not have called that dimension. So we're going to take a break in a minute and I'm going to change that table name before I have a stroke. Unknown table rental payment facts. Select rental payment facts from I beg to differ. And it's going to be, so I don't need that. I can get rid of that. Well, that was painful. This is another reason why you do copies as opposed to views, because once I've made these dimension tables, I could put indexes on them to make these things run faster. So let's just take Why don't we take a short break while this runs? Oh, no, okay. That was an awesome break, everyone. Thanks. All right, so city, district, blah, 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 payment. So if I wanted to do a slice, right, the where clause would go on these. So I would say where this would be city ID. So I'll just go city is equal to Boston and year is equal to 2004. So you can see that basically what this actually did is all of this built what would be a pivot table in Excel. So all a pivot table is a fact joined with the corresponding entry in all the dimension tables. So I just built a pivot, and then I go in and say which rows in that pivot are the ones I care about. So that would actually be a dice because I cut it on 2 dimensions. If I took Boston out, if I took the year out, it's a slice. And so all you'd really need to do is do that. And the way that I would do that, and I'm surprised that I didn't, because this is normally something I would do, is I actually just build the pivot table, because there's not so much data here that I really care about it too much. You would never do that in a real system. But I would just basically go and say, create table fact date customer as, go run that again. So I kind of built, the only thing I'd need to add in here to make a full pivot table would be the staff dimension. And I could do that if I wanted to, but at some point, you've got to stop the madness. A roll-up is, you can actually just go look these things up. I'm too lazy to stand up and draw on the board. Plus, I can't draw 3-dimensional cubes particularly well. A roll-up is, I'm going to take a region of cubes and smush them into one summary cube. So I'm just going to basically take a bunch of, like a subspace, and compress it into a single cube by aggregating the metrics. That's a roll-up. A drill down is the opposite of that, which is I've got a cube, and I can expand the cubes inside it. That's a drill down. A slice is I pick a dimension, I set a value, like the city, and then I just go and get the matrix of all things that have that. That's a slice. It's hard to visualize these things in 3 dimensions, in more than 3 dimensions, but you think about this being like a loaf of bread, you know, is a slice is just literally, I go pick one of the dimensions. So I mean, you can think about a loaf of bread, you can kind of slice it this way or that way. And so you're just getting for a particular dimension and value, the things that match that. And a dice is, or you basically pick kind of a range of values on both sides. So I want the year to be 2004 and 2003. And I want the city to be Boston and in New York. Well, if you think about that, I've taken 2 slices one way, 2 slices the other way, and put them together. I made a smaller cube, and so that's a dice. So slicing is when you do it for either an exact value or a range on one dimension. Dicing is when you do it for, if you dice, you wind up with a single cell. If you make exact, otherwise you do it on ranges. So it is really how many dimensions you're looking at. So this one particular here, all right, so I made the table. So now it's fact date customer. So I'm just going to go close all the tabs other than this. Go make a tab. Just refresh all. Refresh all. You can see that I've got this new fact date customer dimension. I select rows from that. So you can see that this is kind of a little pivot table. So cleverly did not put the fact ID in here. That was kind of stupid. But anyway, so if I wanted to go and say select star from fact date customer where year is equal to 2005. That would be a slice. So I just basically took a slice of it. So you can see that the years are all going to be this. And if I did and country ID in 50, and then what's another country ID? And 39. That would be a dice. So slice, dice, roll up. The easiest roll up is to just aggregate everything in the fact table. And then that's a dice. And this one is a slice. Semicolon that. All right, so this is a dice. So I'll make the family photos bigger. That's a dice. That's a slice. And for the data in here is so small that the easiest thing to do for these things, as opposed to doing these massive joins, is to just go and make the pivot table. So I've already made this pivot table would have facts, the customer address dimension, the store address dimension, and the date dimension. I just built the customer address dimension. I could do the same thing to go make the whole thing. So I'm just going to do select star from actually, I didn't put the values in here, which is kind of stupid. But anyway, if you just join the facts and then with the dimensions one at a time, so join the facts with the first dimension, make a temporary table, join that with a second dimension, as a temporary table, join that with a third dimension. That's your pivot table. And then it's just easier at this point to do the dices and slices against the pivot table. It's easier to understand. And all the slices and dices are where clauses on the pivot table. Just so that you learn a new term, one of the things about that people like about star schemas is They call it the join path is clear, which means you don't have to join something with something else to get it all. So I don't have to like join a payment with, sorry, I don't have to join a rental with the payments and then join that with the customer and then join that with the address to get what I want. It's a single join, and so it compresses all the interesting join paths into a single join, and that's the reason why people do star schema. But anyway, does anybody have any questions about slice, dice, star schema, etc.? All right, we'll take a short break, and then I'll do the final programming question, and we can wrap up. All right.